Hi everyone, this is the second video of the chapter function. The last video will understand definition with few examples. In this video we'll understand about the domain, codomain and about range. These words are generally used while studying the function. Domain. Let me draw a set here. Say this is set A, say this is set. Now let me define the function first. Means all the elements of set A should have a uniquely attached with the set. Right? This was the definition. Now, so this has the three elements. It means all three elements should be linked with here. Let's say this, right? Now this is A, this is B. I can say function F. The direction is this from set A to set B. Okay, different from A to B. Right? The domain is what? All the elements of set A. All the elements of set A for which the function is defined is called the domain. It means if the function is defined, first thing is function is defined and all the elements of set A are called the right codomain. Now set has element and set has some images in the set, or that means all the elements of set B for which the function is defined are codomain. Or in other words, I can say it means set B can have empty elements. सीधी सी बात है कि इसमें से कोई एलिमेंट छूटना नहीं चाहिए. सेट बी में से एलिमेंट छूट सकता है. अगर वो एलिमेंट छूट जाता है तो वो भी कोर डोमेन में आता है. जितने भी एलिमेंट सेट बी के होंगे वो कोर डोमेन में आएंगे. यानी फंक्शन डिफाइन होगा तभी ये चीज पॉसिबल है. राइट? और इन अदर वर्ड्स आई कैन से सेट which contain all the elements of images if codomain is greater than R is considered as codomain. Now it means अगर मुझे कोडोमेन के बारे में इंफॉर्मेशन नहीं दी गई है तो I'll say if codomain is not given the question then I'll consider real set as the codomain. Right? Many of the time codomain is not given, we'll consider the real numbers as the codomain. Right? Or I can say next thing about range. Of images set of images is called range. Means all the images of set A, all the images of set A is the range. Now there is a very thin difference between the range and codomain. Range is the images of set A while the codomain is all the elements of set B, or you can say range is subset of set B. Range is subset of codomain. It means codomain means all the elements and range means the image, all the images of set A. For example, if fx equal to x square is defined from integer to real number. Fx equal to x square. Now it's given integer to real numbers. This is called the domain and this R is called the codomain. Now first thing is the function is defined. I'm taking all the integers. It means x takes the integer values. No issues. X can take all the integers values because x squared is a function, and we'll get the values which are subset of codomain, right? So this function is defined, right? Now here is domain is integer, codomain is real number. What about the range? Here range is if I say integer I, so it starts from minus infinity to plus infinity, and the values would be integer. That means minus 7, minus 6, minus 5, or 3, 4, 5, 6. So its minimum positive value of the minimum value of the integer which is non-negative is 0. 0 square is 0. Next value will get 1, then 4, then 9, and so on. For the negative values it becomes the square. So the range would be like this, and it's obviously is a subset of codomain. It's a real number. Y equal to x plus 6. Function is defined from real to real. First thing is real to real. For any value x, y is defined. Yes, it's defined, and therefore it's a function. Find image of 13. If you have to find the image of 13, it means y equal to 13 plus 6, which is 18. So it means we have to put the value of x here, and the x here is 13, and if I find the image comes to 18. The reverse is pre-image. Find pre-image of 3. It means Here y is 3 and it's equal to x plus 6 and x is minus 3. Pre-image of 3 is minus 3 or image of minus 3 is 3. Now look at this question, this is very important. In a functional mapping, how many minimum and maximum images and pre-images can an element? That's very a basic question. In a functional mapping, how many minimum and maximum images and pre-images can an element have? Now, if I'm talking about the image, say this is set A and this is set B. Now, obviously, the image would be from set A to set B. So, if I'm talking about this images of X. So, the, as a function we define, it should be uniquely associated with the set B. So, I can say has image, for talking about the image, maximum or minimum value would be 1 because it should have been uniquely attached, right? And about the pre-image, that means about the X pre-image, minimum is nothing, that is 0, and pre-image maximum what it can be, pre-image maximum what it can be of, maximum pre-image can be of domain. That means covering all the elements of set A, right? So for the image, maximum minimum is 1, and for a pre-image minimum is 0 and maximum is the number of elements, or you can say its domain. If x and y belongs to real number, which of the following is function? First, y equal to 9 minus x square. Second, y equal to x square. Third, y equal to root x minus mod x. And fourth, y equal to x square plus 1. Think for a while and decide which is a function and which is not a function. Y equal to 9 minus x square, and the domain and codomain is from real to real. For all the real values, y is defined, yes, it's a function. For x square, it's also a function. X square plus 1 is a function. What about root x minus mod x? For the two same values of x, y is same. It can be possible. So because the mod x is here, therefore it's not a function. Because for certain value of x, there is two possible values of y. For example, if I put the value of x here is 1, then y is root of 1 minus mod of 1, that is 0. And if I put the value of x is minus 1, then root x is not defined here. If root x is not defined here, but the domain is real, so it's not a function here, right? Because root of negative number is not defined, therefore we will not able to find image of negative numbers here. Therefore the function is not defined. So it's very important about the range, about domain and codomain, and domain should be completely defined. Domain of important functions: u raised to power v. Domain here is domain of the function like u raised to power v is, can you find out by putting the value u greater than 0 and v belongs to real number, right? Second thing, this is very important over here because many times you will not able to this kind of functions u raised to power v set, that means x raised to power log x or e raised to power log x, or can be it can be like x square raised to power log x. So difficult how to find the domain of these functions. So what you have to do, make this thing greater than 0 and this log x belongs to r, and then find the domain. Second important thing about the function NCR. Many times it's come to permutation combination. Here n belongs to natural number. What you have to do, and because numbers a collection should be a natural numbers, and r belongs to all number because r can be 0. Zero selection is also. And important thing is n should be greater than equal to r because number of quantities cannot be less than the number of quantities that have to be selected. So by these three conditions you will able to find the domain. Third important thing, fx is f1x plus f2x minus f3x upon f4x. Suppose a function is like this, sum and difference of the other functions, or it means the many functions attached algebraically. So here domain of this function is fx is equal to domain of function 1 intersection domain of function 2 intersection domain of function 3 intersection domain of function 4. This is very important here, because we have to find a separately domain for this function and take the intersection. Important thing over here is f4x should not be 0. That intersection is also taken here, right? In the next video we'll discuss about the examples of domain, right, about the few functions. Let me give you a homework. We'll discuss this type of questions in the next video. First is fx equal to 1 upon more, this is what this function is called, fractional part function, right? Second question, fx equal to under root of 4 minus x square. Third is fx equal to 1 upon greatest integer. This function is called the greatest integer function. Try to solve these questions. We'll discuss in the next video. Thank you. Have a nice day.